All right, so do this. Take 10 seconds, and I want you to think of your best definition for domain and your best definition for range. Here's my definition. Domain is all possible x values, and range is all possible y values. But what the heck does that mean? First, we need to talk about functions. A function is a machine. It has an input and an output. In high school math, we call the input values x and the output values y. We can put a value into a function, do some math, and out will come an output, a y value. Now, drawing little machines is fun, but in math class we write equations symbolically, which means they look like this. And remember, the inside of the parentheses tells us what the input to the function is. In this case, it's x. We can say this is a function of x or f of x. Now, in high school, you spend a lot of time making pictures of these input and output values. This is called plotting. And unless your teacher is really out to get you, x, the input of our function, is on the horizontal axis, and y, the output of our function, is on the vertical axis. All right, now back to domain and range. What were those definitions again? Think. There we go. Domain is all possible x values, and range is all possible y values. Let's look at a simple example. So what is the definition of domain? It's all possible values of x. So let's test a possible value. So for example, would the value x equals 1, would that work? Is our function defined when x equals 1? So where does x equal 1? X equals 1, here's the x-axis, so we go 1 unit over. So this is x equals 1. And for x equals 1 is our function defined. Is our function defined in this space on this line that is equal to x equals 1. And if we look up, our function is not defined here. So x equals 1 is out. What about x equals 2? If I plug in x equals 2, here's x equals 2. And if we look up, our function is defined here. So x equals 2 is part of our domain. What else is part of our domain? If we look, x equals 3 is part of our domain, and x equals 4. So there's some examples. So these are all part of our domain. But is that our whole domain? If we keep thinking, we see that, oh, well, what about x equals 2.5? That's part of our domain, 2.5. And then what about 2.6? That's part of our domain. And if we keep going, we'll see there's actually there's an infinite number of points in our domain. And that's okay. It just means we have to write our answer as an inequality. So the way we do that is we say 2, which is where our domain starts at 2, is less than x is less than 4. So this inequality describes every single point in between 2 and 4, and this is our domain. 2 is less than x is less than 4. All right, now range. Remember, range is what? It's all possible y values. So let's ask ourselves what y values are possible. And if we look, we'll see that only y equals 1 is possible. Y can't be 2, y can't be 3, only y equals 1. Y can only equal 1. So for range, we'll write y equals 1. Okay, so domain is all possible x values. So for example, is x equals 0? Is that part of our domain? X equals 0. If we look, is our function defined when x equals 0? And it is. So x equals 0 is part of our domain. What about x equals 1? Is our function defined when x equals 1? It is. What about x equals 2? If I plug in x equals 2, is our function defined? It is. It equals 5, so our function is defined. X equals 3, is our function defined? Well, it's not on our graph, but you can imagine that if we go to 3 and we go up however many units we need to, our function is still going to be defined. And what happens here is if you keep going to the right and you keep zooming out because our function gets really big, it just keeps getting wider and wider and wider and wider. So as our function gets wider, it actually covers every single x value in the whole world. So the way we write that, there's two ways to write it. Way number one is we say negative infinity is less than x is less than infinity. That's one way to write it. The other way to write it is this fancy looking R. I'm going to kind of block this off here like this. So we make an R with two lines like that. And that means all real numbers. So x can be all real numbers, negative infinity all the way to positive infinity. What about range? What are all the possible y values for x? For our function. So let's do a test value. So what about y equals 0? Is that part of our range? If we look, where does y equal 0? It equals 0 right here at the origin, and anywhere left to right, y will equal 0 for all these points. Is our function defined there, though? It's not. So our function does not exist at y equals 0, so that's out. What about y equals 1? If we go up 1 unit, our function is defined there, so that works out. All right, y equals 2, yep, and I think you can see by now that any value greater than 1 for y, our function will be defined there. For any value greater than 1 for y, our function is defined. For any value less than y, our function is not defined. So take a second, think about how do we write this idea in math? How do we write this idea in a mathematical notation? All right, and the way we do it is we say y is greater than 1. That's it. Because all values for which y is greater than 1 is true, that's going to be our range. Those are the values where our function is defined on the y-axis. The first thing I want to do is rewrite the function with a y instead of the f of x. And we're always allowed to do this. F of x and y are equivalent. All right. So back to our definition of domain, which is all possible x values. So let's think about this function, square root of x minus 1. Are there any values for x for which our output is not defined? Are there any input values for which our function breaks, our machine breaks and doesn't work? So let's think about that. How do we break a square root? Is it possible to break a square root or make it, not have an answer? And if you think about it, there is actually. The way you break a square root is you take the square root of a negative number. So for example, square root of negative 1, this does not exist. Now, at some point, you're going to learn that this is actually the imaginary number I, which you'll get to at some point. But for now, we're talking about real functions, so don't worry about this. Just remember that you cannot have the square root of negative numbers. This cannot happen. Okay, so our question then is when, for what values of x, is the square root going to be of a negative number? So one thing we could try x equals 1. If I plug in x equals 1, then I get the square root of 1 minus 1, which is the square root of 0. Is that a problem? It's actually not, because the square root of 0 is just 0. Because as we know, 0 times 0 is just 0. No problem. All right, so when do we run into trouble here? What if x equals 0? If x equals 0, then we have square root of 0 minus 1, which is the root of negative 1, which we said is a problem. So x equals 0, that does not work. All right, so we found a value that is not part of our domain. So the question is, where is the break point? When does x begin being problematic? So we know that x equals 1 is fine, and x equals 0 is not okay. But where in between these two values does our function start running into issues? When do we start having problems? The question is, when is the inside of the square root, when is this just barely negative? So for what values of x make the inside of this just barely negative? And if we think about it, if x is any smaller than 1, like if x was, if x was 0.999999999, just a little bit smaller than 1, then our argument, the inside of our square root, would become negative, because any number that's less than 1, when we take away 1, we get a negative number, okay, because this number is less than 1. So if you take away 1, your answer has to be negative, and that's a problem. So our conclusion then has to be, we have to conclude, let me slide this up a little bit, that our domain, think about it carefully, how do we write our domain? Our domain is going to be x has to be greater than or equal to 1. Because we decided that if it's any less than 1, we have a problem, and we decided that 1 is okay. So anything greater than or equal to 1 is fine. That's our domain. All right, and now range, let's think about range. So this one's a little tough, but think about the values that y can take. So for example, could y ever be negative? Is there anything we can plug into here that when we take the square root, we'll get a negative answer? And the answer is no. There's no way to make a square root, the result of a square root, negative. Okay, could we ever get a 0 for this? Well, if I look here, I see that if I plug in 1, I actually do get a 0. So 0 is okay. So that means our range is anything, including 0, but not negative. So we write that, we write y is greater than or equal to 0, and that's our range. So what the heck is that? If this happens, I want you to drop out of school immediately. Alright, so we're looking at a set of ordered pairs. I know it's a set because these fancy brackets in mathematics, they mean a set of numbers, a set of ordered pairs, a set of whatever. In this case, we have ordered pairs, so this is a set of ordered pairs. And whenever you see a set of ordered pairs, remember that x comes first and then y. It always goes input and then output. I like to label these just so I know. And now let's think, what are all possible x values? What is the domain? And actually the domain isn't too bad at all. So our domain, it's all possible x values, and they tell us. So the x values are 0, -1, 7. Those are all possible x values, because this relation, these numbers, represent the entire function or relation. That's it. And now our range, pretty easy. Our range is just 2, 8, 2. There you go. And that's it, domain and range. Now, if you don't practice, you're gonna forget this in like 5 minutes. So please do the following exercises.